Hey everyone, this is Olan here again. I know we presented this last night, but I just wanted to record it this time. That way you guys could come back and reference it. And also, since we did fail to record our meeting last night, I just felt it would be good. So this presentation is over the loops, variable statements, and much more. The title was pretty long, or the amount of topics that I had to cover was really long. So we'll just dig right into it. So first off, I wanted to start off with loops. Not sure how many of you have actually done lots of programming in your past, but loops are just a way to iterate over code multiple times. Or another way to put it is it is conditional repetition. So you can loop through something in three different ways in JavaScript. There is a for loop. The for loop is usually utilized when you have a set amount of times you need to go through. So like in the example here, it starts at 0 and goes to the length of the array uh, that it has up above. So 0, 1, and then 2. And then once it hits 3, because the array length will return a 3, but it's less, I is less than, or 2 is less than 3, but once it hits 3, it'll exit. So but that's a for loop. It has a set number of times that it's going to go through. There's the while loop that the use case for that would be if you do not have an exact amount of times that you know it's going to go through. You just know a certain condition that it needs to meet when it can exit. Now, the one difference between the while and the do while, because they both look the same, but the while loop will check before it enters the loop, and the do while will execute the loop at least once before it checks. So that's the difference between the two. So if you know you at least want to execute your code once, you're going to use the do while. Otherwise, you'll just use the while, and if it's already matching, why even execute the code that you don't need to match anymore? So that's the examples here. Now, there are two other things that are controls for loops. There's the break and continue. Break can be used in loops to exit when you found a condition in the middle of your loop. It literally jumps just to the first line right after the loop itself. So in this case, if I had a break right here at the top between this message and the I++, it would do the check, and if it matched, it would then hit the break and then jump outside of it anyways. So that loop would never be hit. The continue, on the other hand, though, you can have a continue in there in the event that you don't want to continue executing certain code in your loop. You just want to jump to the next iteration. So in this situation, let's say I wanted it to be I to be less than 10, but there's also another condition I need to make that I would say if message does not contain this, then continue. So then it would jump from there to the bottom and reiterate to the top. So it could keep doing that while jumping through that over that code that you don't want it to execute. So that's two other control mechanisms for loops. Now, conditional statements are utilized in programming and multiple times. Now, the table I've got here covers a lot more than just the conditional statements. It also has some math operators in here. But for all intents and purposes, the relational, this number 6, all the way down to conditional, are our conditional statements. You can use them in decision-making processes for like your while loops, your for loops, an if-then statement, which we'll talk about here in a bit. But it's just a way to check certain things. So if x equals y, or if x plus 10 is greater than whatever, just depends on your logic and what you need to do. But these are the operators that you can use to execute that. Now, the comparison operators, which are these here. Sorry, I actually just noticed I've got this on the wrong line. It should be down here on the logical operators. But comparison operators are where you're checking one thing against another. So there's equality and there's relational. Now these logical operators, which are the and, these double ands and the or and the double or, that's where you have both the normal and the short circuit. The double and the double or are the short circuit because in the event that, let's say you have double and between two statements. If the first statement is false, you already know no matter what the outcome of the second statement is, your overall statement is going to be false because of the double and or because of the and. So if you short circuit it, if the first one fails, it's just going to move on. It's not going to waste the processing cycles to check the second statement. Same with the or. Let's say your first statement is true. So now it doesn't care if the second statement's true or not either, because it's already met one true. It can just move on. Now that's different in an XOR because you want in an XOR it's one or the other, but not both. So if and if else, these are statements where you're basically saying if it's 7 o'clock in the morning, then my alarm will go off. That's kind of what you're basically doing with these statements. You do an if with a conditional check or a statement to check something, and then there's a action to be done. And by chance, if there's another option, so let's say if this is not true, then I have something else I want it to do, then you can have the else statement. And these can chain multiple times. So you could have if this, then that, else if this, then that. It can go on and on, which is actually why the switch statement comes up. Switch is a way for you to give the switch statement a variable to look at. And for each case, you can have it do specific code. So there is the main switch statement, and then you have case with the value of what it could be for that specific case, and then you do all of the logic underneath it that you want it to do for that situation. Now, functions are an easy way for you to write repeatable tasks and then just call them by name. You create a function by defining its declaration up here. So you say this is a function, its name's congratulate. It doesn't have any input or any type of parameters as part of it. And all it needs to do is it's going to take the global variable of message and add congratulations to the end of it. That's the repeatable code right there. Now in here in this function call, he does congratulate, he calls the congratulation code, and then he appends proceed to next round to the end of that again. And that's only if the score is greater than or equal to 50 in this case. So that's a function at its high level. Now, functions can be done in a couple of ways. You have anonymous functions and immediately invoked functions. From my reading and understanding of it, anonymous functions are utilized when you want to store a certain value into a variable. So let's say message had certain things that it needed to have put into it based on some inputs. So you'd have function with the two inputs that you would have, and then you would do your arithmetic or whatever steps you needed to then insert that value into message. Immediately invoked functions are things that you can just execute as soon as it basically runs over it. I hate to, that's the only real term I can put to that. When it's executing from top to bottom, and so when it runs over it, it hits that line, it's when it'll execute that. Now, variable scope in this situation, he's defined message as a global. Global in the sense that you can use message in this function in this area here as well. Now let's say he had defined message inside this function here. Now the scope for the message would be stuck inside the function of congratulate. And so to get anything useful out of this function, you'd have to have a return statement So you could store it into whatever variable outside of that scope. But scope is, if any of you have taken a Java class, scope is critical for you to understand, because otherwise you'll get error messages where it'll say an undeclared variable has been used, etc. So always understand your scope and that you are using your variables appropriately. Now, to talk more about variables, it is just a name storage space for data. You give it a name. You don't even give it a type when you first declare it. Like in Java, we would have to specifically tell it you're an integer or a float, or you're a boolean or a string. In this case, you just call it or declare it variable name. And then when you assign it a value is when it actually types it. It gives it a type. That's why it's called loose type in JavaScript, because it sets the value when you put data into it. Now, the three native data types of JavaScript are numeric, string, and boolean. So here are some examples of the numeric right here, the string, and then the boolean. Now, parameters, I mentioned that a little bit earlier when I was talking about functions, but parameters are just pieces of information that end up getting sent to functions. You can either make them variables, or you can make them hard-coded, like a number of some type. Let's say you always wanted the width here in this function to be 3. You could just put the number 3 here and then height, and then it would do its arithmetic here. But in this situation, whenever I call getArea with the 2 parameters I send to it, it's going to send that data into here, assign the first parameter to width, and assign the second parameter to height, and then perform that arithmetic and return the answer. Normally, you're either going to be printing it or storing that value in another variable, wherever you call the function. But that's what the parameters are for. It makes, in my opinion, it makes functions even more versatile and usable, because I can give it whatever information I want to down the road, and it will react dynamically to what I need it to do. Now, arrays are just like a list. It's like a grocery shopping list. You have all these different items on your grocery shopping list, but they are still considered on one piece of paper, which in this case, colors, that would be your piece of paper. And the list contains white, black, and custom. Now, to call each of those elements, you reference them by their position within the array, starting at 0 up to the maximum amount of that array list size, which in this case would be 2. Now, these arrays can store any type of data, from the native data types of string, numerical, and boolean, even to objects, which objects we'll talk about on a later date, but objects are just simply multiple variables combined into a single item. Like, let's say a car, you want to describe it by its VIN, its color, its make, its model. You can make those specific attributes all part of a single object. But you can store objects within arrays as well. Now, arrays can be multidimensional, kind of like Excel is multidimensional. Now, granted, multidimensional arrays can get even deeper than just 2-dimensional, like an Excel spreadsheet. But I have actually never used anything above a 2-dimensional array. So in this case, you can make multi-dimensional arrays as well, which, again, just think of it like an Excel spreadsheet. That's all it's doing. And unlike Java, when you created an array, its size was static. You could not change the size of that static unless you used another variable type that was expanded across upon the basic array type. But in JavaScript, you can either use the .push function, or you can just assign the next value up. So in this case, we've got 0, 1, 2, and let's say I want to add red. So now I could do colors of 3 equals red. and then it would append red to the bottom of this. And then finally, associative arrays. So some examples of what associative arrays are like maps in Java and like dictionaries in Python. They are ways to create a list of items and call them by, or basically an object with a list of items underneath it, and call that each individual item by name rather than by a number. JavaScript does not have that capability, so what it ends up doing is it creates basically an object for you. So you end up with your variable name here, and then it ends up appending, so city is a part of that object, and it'll assign a value or an attribute of string to this. So you have a variable underneath your object of city, which has the contents of Portland. And same for state, except it contains Oregon, and country, but it has United States. So now you have an object that has 3 attributes to it that are now named in the sense that you're calling the actual the attribute by its name. So, but that's what how you would define an associative array in JavaScript. It's not really there by definition, but it's identical in the way you call it and define it. So I tried to reference all my sources in the presentation itself, but I wanted to give you guys this page here. The majority of everything I got from this was from John Duckett's book here, JavaScript and jQuery. I know jQuery isn't part of this this class, but almost the majority of the book covers JavaScript. So, and I like the way he writes, so I use this book quite often. And then these 2 URLs for the operators as well as the associative arrays. I hope you guys enjoyed it, and I will talk to you guys later.